Hi, good afternoon everyone who is online for this Taiwan Space Union, the first online lecture of 2026 about GIS, remote sensing, and some other issues. I'm today's lecturer. My name is Tien-Yin, so I'll start my lecture. My talk today is about the geospatial science for sustainability. So I'll talk about the core GIS and remote sensing, which is from maps to monitoring and from data to the decisions. This is a series of online courses about the GIS, about the agriculture use, about the AI. So I'll start the GIS and remote sensing from now. My name is Tien-Yin. I'm a professor and I'm also the chair, the director of the GIS Research Center in Fengyang University in Taiwan. And I'm also serve as Open Geospatial Consortium Asia Forum. So I've been constantly host some kind of OGC Asia Forum around the Asia Pacific area. And I'm also the Secretary General of the Asia Pacific Federation for Information Technology in Agriculture, which is called EPIFITA. So it's my honor to give you the first lecture this afternoon. So I'll talk about the GIS fundamentals, about what means by the data, what means by the layers, and why we need the coordinates and analysis to tell us where we are and what things are happening now. And also how we can use the remote sensing fundamentals, like the different kind of sensors from satellite, from air photo, from UAV, or even from some kind of ground surveying. And the resolution counts. And all this kind of image, how we can use that to analyze. So how we can use the UAV, how we can use the satellite, and nowadays everyone is using the AI. So what kind of AI application for the sustainabilities? And I'll talk about, once we have so many different kind of data, how we can wisely use the kind of data cube and to create some kind of, we say, smart city, or even for the 3D city models about the digital twins. And also to provide some kind of decision dashboard. So the key messages today, I'm going to talk to you about the GIS, about remote sensing, about how the AI can become a decision intelligence, and hopefully this course will be useful for you. So let's start with the geospatial process. So geospatial process about the digital geoinformatics, which means we need to have all the kind of analog data sets into digital data sets. So we need to capture, we need to manage all those data sets and analyze all those data sets, and we can deliver to whomever needs all this kind of data sets. So that's the full process, and which is very, very important. So today I'm going to give you some example how we can use those kind of process and what kind of process is needed as a GIS and remote sensing foundation. So what's a GIS? We've been talking about this for over 30 to 40 years. So the GIS is about the integration of relevant spatial data and also the foundation for all the geographic data sets. And the GIS can support for data extraction, editing, updating, storage, querying, processing, analysis, and visualization, which can be used by the decision makers. And for nowadays, we use that for sustainability, we use that for disaster management, we use that for smart city, for smart agriculture, everything. So the component of the GIS, which should include the hardware, of course. We need the kind of very good server. We need the kind of very, very good communication. And we need software. And from very, very long time before, the software start with a very good some kind of business development, like the S3 product, and like lots of different kind of software. And nowadays, lots of people use the open source one. For example, like QGIS, like OpenLayer, and all this kind of software can be provided in the world. And all those data. So I'm going to talk to you about more about how we can get those kind of data sets and what we can use as a GIS with remote sensing data sets. And we need people, we need organizations, either from the governmental agencies or from NGO, because lots of data sets, not only collected by the governmental sectors, but also we say all the different kind of NGOs, they also provide lots of very, very good data sets. For example, like the OpenStreetMap is one of the very good example of the GIS teamworks. And also we need model, we need methods, we need algorithm, because we learn from historical information, then we know how to process it, and then we can predict for the future. So that's very, very important for all the decision makers. Let's see, there's so many different kind of information. There's so many of them existed around the world. So because all this kind of information nowadays, we can just very wisely use that, either from the satellite or from air photo, or even from the drones or UAVs, or from the ground survey. So there are mediums, tens of mediums, data sources every year, even every day. So how we can analyze those kind of data? For example, like the data in the GIS. When we talk about the GIS, fundamentally, we talk about two kinds of data structure. One is a spatial data, one is attribute data. And for those kind of spatial data, we know we have the point, we have the node, we have the line, the arc, the polyline, the polygon, the area, the region, the surface, the three-dimensional. And now we even have the different kind of remote sensing used data structure. And for the attribute data, we say that's the data, use the text and numbers or whatever to record those kind of geographic elements. And there are several structures of this kind of attribute data, like a nominal data, ordinal data, or interval ratio scale, to describe all the graphic information. So we need the graph, we need the attribute data to really join together as a GIS database. So I think that's the basic things. And what about the criteria of a map? For example, like this is one of the very historical information about historical grassland in the continental of the United States. Like all the grassland about different kind of the forests or different kind of trees, all those kind of example. So there are so many different sets to represent in the GIS map. There are data legend, there are title, there are lots of things to describe in the map and also with those special information. So special information is how we can tell about the location. But for location, we need to first realize the projection and coordinate systems. For example, we say the Fengyang University locates at the number 100 Wenhua Road in Taichung City. But how can we compute the locators? So we know the Fengyang University is located at certain latitude, certain longitude degree. So that's how we can really locate, use the longitude, use the latitude. So convert the Earth into a standard kind of ellipsoid, generates the coordinates. But every location has a unique coordinate. But because the Earth is not a flat one, So we need to have some kind of geodetic data. In the world, there are so many different kinds of geodetic data, like the WGS 84, which use the longitude latitude to describe most of the locations. But for each country, depend on the country size and depend on its own rule. They all have different kind of, like universal transfer mercator, like the UTM is a 6 degree of the longitude changes. Or in Taiwan, we use the transfer mercator 2 degree because we are from 120 to 122, mostly in the Taiwan island. So also the geo ID is not a flat one. It's an irregular surface and usually using the average sea level as a geo ID. So there's lots of scholars, experts talk about the geo ID, the data and everything, and how we can very precise locate each location. So the geodetic coordinate system is a kind we use the latitude, longitude, that's the most common one. That's the most common one. So like we have the equator, we have the measuring to describe about the latitude, about the longitude. And also there are different kind of projections maps. Historically, there are lots of very good experts in the geography, and they describe into different kind of the projection methods. There are so many, majorly, there's so many different kinds. Here is only the 3 basic one, as how we can use the conic, how we can use different kind of maps to describe how we can use the 3-dimensional thing into a 2-dimensional, the map one. So we need to choose a projection based on the purpose, the scale, and location. And from each different countries, we all have different kind of projection being commonly used. So the structure of the GIS data is, once we have the location, we know where has what. But we need to use the point, the node, the line, the polygon, the region, the area, and the surface to describe the entire environment. Because in the real world, it's a very complex information to describe the real world about our environment. So basically we can describe into vector data, like I said, like the node, the line, the polygon, the area, the region. Or we can use the rest of information, such as those kind of information being collected by the drones, by the air photos, by the satellite images, or by any kind of different kind of sensors. And then join that together into different layers, into different kind of coverage. Then we can have a very good digitized information about each layer to describe our environment. So that's the basic information about the GIS. So the GIS is to collect all those information and use the spatial information and attribute information as a map to describe where we live, to describe what kind of changes, to describe everything. Where is the location and the size of that and the impact of that. For all those kinds of information, then we can join together with some kind of model, some kind of algorithm. Then we can describe, we can use that to predict. And so that can be used as a decision maker. So that's the most important one. And when we compare with the vector and the raster, and we can exactly know, like the vector use the point, the line, the polygon. And the raster use this kind of images. An image we describe as a pixel, or each cell, or we use different kind of resolution to describe the raster information collected by remote sensing. So this is also a kind of comparison between the line information and also the kind of raster information. So when we compare with the vector information and the kind of raster information, we know the vector information about the points, about the line, about the polygon is how we can describe at the upper images. We have the point, we have the line, we have the arc, we have the polygon to describe the entire area. But if we use the raster information, such as those kind of images captured by the drones, by the air photos, by the satellites, then it depends on the resolution, depends on the cell size. So that means by each pixel, we might have the points. We can use different pixels and describe about the lines. We can use a pixel to describe about the polygons. So this are the basic difference between the vector and the raster. But nowadays, because all this kind of information, all this kind of resolution has become very detailed now. So nowadays, two kind of data structure is commonly joined together and used as very, very common used now. And also another information, very, very important, like the digital terrain model. It's trying to describe the real surface information using the kind of irregular triangle information. And we can use the raster grid as the elevation values in each cell or each grid points, and which is simple. Or we can use a Tien-Yin like this one. So the raster grid means each grid has the elevation inside. And if we use the Tien-Yin, and it means we use the triangular networks. So every point is connected, form some kind of triangles. And each triangle represents a planetary facet. And it's very suitable for complex terrain representations. So nowadays, we can use either raster grid or the Tien-Yin to really describe the surface of each different environmental location. And let's talk about remote sensing. As we say, what is remote sensing? Remote sensing is a kind of measurement of object characteristics without the direct contact. So, for example, nowadays, the remote sensing in 2026 has been improved a lot for the past almost 50 years ago. Like there are so many different kind of multi-sources by satellites. There's so many satellites being launched to the orbit each month or even each day. There are image satellite, there are LiDAR there are different kind of satellite. There are satellite for weather, for image, for communication, lots of. And also there are so many drones, the UAV, and aerial photos by the aircraft. And also we can use lots of different kind of field sensors like to surveying. Like surveying now, we use like the total station, we use the LiDAR nowadays. So there are so many multi-sources now, and there are so many multi-sensor, the optical one as a traditional, the image one, the SAR, the thermal, the LiDAR, the hyperspectral. All these kind of sensors can send back all the very good real-time or even the historical information. And multi-temporal, like lots of the satellite and also the drone can be easily deployed to each location. So we can do daily monitoring or even a long-term archives information. And every information uses AI enabled, because all those kind of information can be transformed into a digital format. And the AI will be able to understand that. And once AI learn how to analyze that, then the AI can probably make very good prediction, like the object detection, the change detection, and also making the predictions. So the decision oriented for the disaster, for the agriculture, for the cities, for the sustainabilities. And how we can use images. For images or the sensors, they collect the wavelengths by the spectrum. So based on the different wavelengths, remote sensing can be categorized as visible near infrared, infrared, or microwave. Or as we can see, the human eyes can only detect a very, very small one, while the infrared, radio waves, or ultraviolet, X-ray, or even gamma rays has different kind of frequencies and wavelength. So we can use different kind of sensor to detect something. We'll not be able to see that, but we can detect that. And use that kind of information, we can do lots of things using the kind of remote sensing. So the advantage of remote sensing is it's able to obtain the large area information in a relatively very short period of time. When the satellite passing your area, it's only in seconds. And information can be displayed in forms of graphic or non-graphic messages and reduce the manpower in before and also the risk of some kind of operation. For example, like we use a drone to deploy after each kind of like typhoon event or some kind of floods. It reduces lots of this kind of manpower and risk. So the remote sensing can really support not only the small area, but for very, very large areas. For repeatedly, we need lots of information daily, hourly, and much safer, and also timely observation. So in the world, there's so many very useful satellite images. It's being conducted by either private company or by the governmental sectors for different countries. And lots of this kind of satellite image can be very easily accessed through different kind of exchange or website information, or even you purchase that. So there are lots of this kind of information is already available. And for aerophotos, there are lots of this kind of aerophotos still existed in many places along the world because it can produce very, very high image quality and very high spatial resolution and very large scale images. But it can be very easily affected by the weathers because once it's too crowded, it's raining, or even because of the sun and lots of things. And also it's really hard to transfer information directly back. So it's hard to have the real-time information. And for example, like this kind of aerophotos, the resolution really matters. For example, the 50 centimeters of resolution or the 25 centimeter or even to the 10 centimeter, it can produce a very good different kind of scale of the GIS map. And from the satellite image, there are so many satellites on the orbit. But lots of them are for either communication use. And some of them are for location, and some of them are for images, some of them for weather. So there are so many different kinds of satellites. Like in Taiwan, the government has already launched the Formosa number 8. So there are more satellites coming, even from Taiwan. And there's so many satellites can provide lots of this kind of information. And for resources, we talk about the resources satellite. We use this kind of images. We use this kind of information by the near infrared, by the thermal, by different kind of multispectrum. So the satellite can really cover very large coverages. Aerophoto can have very high spatial resolution. And UAV can have very, very high resolution and very rapid deployment. So depending on what kind of purpose you need, you can decide either you use the satellite image, aerophoto image, or even the UAV. And the best practice is to integrate all three kinds of information with GIS layers and field data. I think that's the major, we say, the sustainability. You cannot just count on one kind of source. Lots of time we need satellite information because it provides a large area. It provides lots of historical information. But we also need air photos because we need a flexible location acquisition. And lots of time we can use UAV as a task-oriented sensing. So most of the time we need three kind of sources, like the aerophoto one, for example, like the UAV combined with the Internet of Things, with the AI, with the service platform, and most of the commercial drones equipped with a visible light camera, but there are lots of things is coming. So what about we take a lot of photos and link them together? So there are different cameras, different sensors, even with a UAV. So nowadays, if we talk about a smart city, we use a lot of UAV information because it's easily to deploy. So the common UAV mounted sensors, there are RGB as a traditional one, the most common sensor, and can give lots of very good, very high resolution images, video, even in the night, and live streaming video. And thermal one. Thermal one can receive the thermal signal and good inspection. Or there are directly the AI inside can analyze the NDVI about the kind of vegetation information about each location. So basically this kind of UAV is for agricultural purpose, different light spectrum to detect the plant health. Even nowadays, there are LiDAR camera. So LiDAR camera equipped with a UAV, so it can use the LiDAR information to really detect lots of information now. So the UAV can really equip with lots of things. And that's why in the world, there's so many drones can be used for show, for lots of things, even for military purpose. But we talk about the drones for the resources, the resource detection, resource changes. So the application of the visible light camera about aerial survey, use mapping or fix the altitude and speed and combine the photos by common ground features. So that will be very easy to get all information. Even nowadays, the UAV might be able to replace lots of those kind of huge aerial photo equipment because of the updated technologies. So the UAV for mapping now, we can use a UAV and together with the ground surveying, so the field survey, the ground control point marking, and we can very easily to really identify the very, very precise map now. Even use RTK or use a GNSS by different kind of satellite surface as a positioning, then we can join together about the image calibration and photogrammetry and use for the orthophoto, even for the digital service model productions. So even nowadays, the UAV can have very accuracy assessment and make very good surveying report because it can create a very, very good surveying data sets. So this kind of RGB camera can be used for disaster investigations. Like the image analysis, we can use this kind of UAV created images to identify the changes of this kind of landslide area. So the UAV can really provide a very good important information for emergency services nowadays. And also the NDVI camera equipped with a UAV nowadays So you can very easy to detect about the vegetation changes, about where has the bare land, about how the grass, how the forest exists. So using this kind of very easy NDVI sensors, we'll be able to tell how this kind of vegetation is going on. So, or use a thermal one. Use a thermal one, we can detect about the different ground temperatures or even different layered one. So the UAV can equip with a very good thermal camera now, like the heat island effect. How we can reduce that based on this kind of information. And we can use very, very good high accuracy of the aerial photo created by a UAV together with ground surveying. Even for the land waste monitoring in Taiwan, there are lots of examples using the UAV and ground surveying together. So even the UAV nowadays, it can be a very easy autopilot by very good software coding. So software coding can deploy the UAV by itself. So the UAV can be no longer be controlled by a very expert. It can be controlled by the programming coding and to detect, to find, to get all the information directly and for the real time transmit it and use different kind of AI to analyze that. So nowadays, we can use lots of this kind of UAV information to analyze a lot of things, which is really hard to get before. Like before, it's really hard to get some kind of three-dimensional model, but now we can use the UAV, we can use lots of this kind of information to create a very good digital twin for each different kind of historical buildings or for any kind of like waste management or any kind of land changes about the digital twins, lots of things. So even with the thermal, like this is a UAV equipped with a thermal sensor along my university campus area. So it can be very easy to detect in a real time about how many traffic on the road in the night. Or is that a truck, or a bicycle, or a motorcycle, or a pedestrian is walking on the street. So it can be very easy to detect and very easy to use this kind of AI model to identify what the object is and what about the location, about the volume. Even nowadays, we join together with AI, we can very easy to take out all the cars on the street. So very easy, the AI learn how to take it out. Then all the images before can create a very clean images now in very short time. Just ask the AI to do that. It can delete all the vehicle on the street. So like all the vehicle on the street, it just take it out, but I still need the real information under this kind of vehicle. So the AI will find all the historical information and all the kind of different photos, because for each ortho photo we created, we have lots of each position photos about the ortho photos. So there are at least 80% of the overlay. So there are lots of the other photos, and we can ask the AI to do that. So AI will be able to simulate or to really recreate the real things under this kind of vehicle when the vehicle is taken out. So once the vehicle is taken out, I still need the road information about what kind of information is on the ground, because I need to do that for the traffic, not only for the image, but I need to know if this land is allowed to have a left turn or not. So all this kind of information is very, very important for a very good traffic management. So that's why I need all information under the vehicle. So this is what I'm talking about all this kind of GIS is not serving only as a map, but it's serving after you analyze that for your purpose. So now we talk about the three-dimensional model, like the city model, the building model, or even with the map object identifier. So it's not only for the two-dimensional now, it's also for three-dimensional now. And based on different kind of international standards like the CDGML, those kind of things, like the BIM model, we can very easy to have all this kind of information get together. But what we can do after all this kind of information, by the drone, by the satellite, by the ground surveying, by lots of historical photos, so Taiwan started to develop the data cube, which means there's so many kind of information. And the database traditionally is not enough, and it's hard to be analyzed by the very quick AI algorithm. So we need the data cube, which means we need to have a way, for example, to have the NDVI, the time series vegetation changes, because there are thousands of these kind of images, and it's a large area. So we need this kind of database. We need this kind of information to get together. And also nowadays, everyone wants to have a three-dimensional one, not a traditional two-dimensional, or even with the ground information using the historical satellite information or some kind of aerial photo to identify lots of things. So it's from 2D to the three-dimensional now. So in Taiwan, the government is trying to produce a very good digital twin platform in the entire Taiwan. So use the satellite image, aerial photos, three-dimensional models, everything. Use the GIS to describe a lot of very, very detailed information about each city, about each building, about lots of this kind of information. As this one you can see, it's a joint combination, it's an integration. Use a satellite image, use an aerial photo, use a three-dimensional model, use lots of information, get together, and use a data cube technique to display and also to analyze. Because this is not only to look at how it looks like, but to analyze that. For example, if we put the GIS information together with the text information with the real three-dimensional building information, the House Tax Management Bureau is happy to use this kind of technique to find out, oh, this kind of suspected violation building, they've been here for many years, but they never pay for the house tax. So this is one of the real application now. Even in Taiwan, lots of the city government, they try to use this kind of GIS because the GIS can integrate with lots of different layers, coverage, as a 3D, the city management. It can produce lots of information, even with the cadastral information, the land use zone, and the building one. Like this one. This is the three-dimensional city management for the Taichung city. It has all information inside. It has the satellite information, aerial photo, the drones, the CDGML, the three-dimensional vector information, use the GIS, even have the BIM model. So lots of information is available nowadays. So today I talk about how we can from the maps to the monitor and from image to the intelligence. So the GIS can provide the spatial context. For example, where are things, how are they connected, and what patterns exist. And remote sensing can provide repeated observations nowadays. Use the satellite, use the UAV, the drones, use the aerial photos, the aerial images, the thermal sensors, the LiDAR, and the multispectrum sensors, and also the field sensors can help us monitor all the changes to identify location, to know the changes, to know what is real exists in our environment. And the AI can transform the images into intelligence, because the AI can learn from the patterns, can learn from all the algorithms, can learn from the large language model as the object detection, as the change detection, and to predict. And it can be very useful for any kind of decision support. And also, there are digital twins existed now, because all the GIS information about all the satellite information, so the digital twins connected analysis with the action. For example, now we talk about the smart cities, the three-dimensional cities, and we use the dashboard to manage lots of the governmental governance managed issue. We use the data cubes because there are so many data, not only for the two-dimensional map, but also the three-dimensional, and not only for the visible one, but also the underground, also the kind of near-infrared information, and also the real-time platforms. Because we have the Internet of Things, we have the sensor, we have the camera, we have lots of things to identify what is the real time. And all of this can support the sustainable governance. So this is one of my major topic today and this afternoon. Talk about the GIS, about the remote sensing, and when it's joined together with the AI nowadays, it can make a very good sustainable decision intelligence. So I think that concludes my talk today, and very thank you for your attention. My name is Tien-Yin. I'm the director and the professor in the GIS Research Center in Fengjiang University in Taiwan. And thanks for the Taiwan Space Union to arrange these online courses. And this is the first one. So the second one will be on the July 20th, still the 4 p.m. in the Taiwan time zone. So check about what is your time zone. So welcome you to join the next Taiwan Space Union online lecture. Next one, I'm going to talk about the AI in agriculture. Why I talk about agriculture? Because agriculture is one of the major issues, especially for the Asia Pacific area. Lots of things depend on the agriculture, and agriculture area and the zoning things been changed a lot. So how we can use the weather alerts and remote sensing analysis to help with agriculture development in each countries. So why you need to join for the next lecture is you can learn about the satellite UAV data can support the crop monitoring. How we can use that for crop monitoring, and understand about NDVI, about weather data and field sensor integration, and see how AI can support early warning and farm decision making, and explore how the space data can help with the climate smart agriculture, and also to connect the GIS, remote sensing, and the AI into a real applications. So the key question for the next time is how can AI turn the weather, satellite, and field data into a better agricultural decisions? I think that will be very useful for lots of the Asian area countries and lots of the scholars or students or experts in the world. So hopefully I'll be able to see you in the next Taiwan Space Union arranged courses. And also allow me to put a good advertisement is one of the Asia Pacific Federation for Information Technology in Agriculture, which is called EPIFITA. EPIFITA constantly hosts a universe conference each year. Like last year was in Indonesia, and before that was in Japan, before that was in Vietnam, and before that has been hosted in India, in Philippines, in Thailand, in lots of those countries. So I would like to see all of you will be able to join the 16th International Conference of the Asia Pacific Federation for information about agriculture. It's on November 4th to 6th in Taipei. So my university, my research center is one of the co-organizers. And it's joined together with the Open Geospatial Consortium. So there will be a Asia Forum session and concurrently. And is major sponsored by the Ministry of Agriculture in Taiwan. So I would like to see all of you will be able to join this Epifita event. And thank you again for your listening this afternoon, and hopefully I'll be able to see you next time. Thank you. So next, allow me to have a very simple quiz after my speech. So these are very, very simple quiz, and you are invited to have the very good answers about all this quiz to demonstrate if you really learn something directly from my speech. As a closing one is, I try to say, the GIS remote sensing and the AI is from maps to monitoring, from image to intelligence, from data to decision. So make the sustainabilities. So thank you again. Hopefully to see you next time. Bye bye.